Okay, so we're going to start on another unit. First off, your next test, I'll already tell you right now, is next Wednesday. Okay? Same day that those cumulative reviews are due. So you got a test next Wednesday over Unit 10. Unit 10 is only 3 lessons. So do lesson 1 today, lesson 2 tomorrow, lesson 3 on Monday, review Tuesday, test Wednesday. Okay? So up until now, we've been doing indefinite integrals. And as promised, there were these things called definite integrals where we suddenly put numbers in front of that integration symbol. And so we're going to take a look at a geometric view of the indefinite integral before we get into any kind of algebraic view. So we've got this function f of x, and f of x is this curve right along here. Okay, and it's actually a piecewise function if we were to write out the function. Notice we've got a linear and then a linear, right? So some positive slope and then a constant slope. So it says redraw the function and shade the area bounded by the function, the x-axis, and the lines x equals 0 and x equals 15. Okay, so let's start by redrawing our function. So let's do our x and y axis. And I'll put 5 and 15 on here. And we've got 2 here. And so notice when we get to 5, that's when it goes, when x is 5, that's when the line becomes horizontal. It says shade the area bounded by the function. So bounded by, like your backyard is bounded by your fence. Okay, so it means surrounded by. So it's bounded by the function above, the x-axis below, the lines x equals 0 and the line x equals 15. So x equals 0 is a vertical line, and x equals 15 is a vertical line. Okay, so bounded above by the curve. Now notice on the left, it's not really bounded by x equals 0 except for right at this point, right? And then it's right here. So we shade in this area. Okay. Now notice that this area is made up of 2 shapes. We've got a triangle, and we've got a rectangle. Okay. So the area, well, the area formula for a triangle, recall, is 1/2 base times height. So the base of this triangle is 5, and the height of this triangle is 2. So that gives the area of the triangle plus the area of the rectangle. Well, the base of the rectangle is 10, is 5 to 15, and the height is 2. So 10 times 2. And so half of 5 times 2 is 5 plus 20. And so the area is 25. So the area we just found is called the definite integral from 0 to 15 of f of x dx. Okay? The definite integral, which is this notation, notice it's the same integration symbol. Now we have numbers, a and b, of f of x dx, is interpreted to mean the area bounded by the curve of f of x above, essentially, the x-axis, and the lines x equals a and x equals b. So these numbers tell us on the x-axis. Okay? Let's do an example of this. It says consider a function f of x that is the upper half of a half circle of radius 5 and centered at the origin. Find the values of the integral from -5 to 5 of f of x dx. So let's start by drawing a picture. It says it has a radius of 5 and it's centered at the origin, which means that it's going to go to +5 and to -5. Now, how high up is it going to go if it's centered at the origin? So it's going to go up to 5 because it's a circle. And so we draw our semicircle, which might look a little bit like a parabola, but it really should look more circular. Now again, the integral from -5 to 5 means that it's bounded by the curve. All right, so in this case it's bounded above by the curve. The x-axis, so in this case it's bounded below by the x-axis, right? And then the line's -5, 5, so it's actually right there where it actually touches. So we're finding this whole area, which is the area of half a circle. Right? So the integral from -5 to 5 of f of x dx is going to be 1/2 of, and the area formula for a circle is pi r squared. Oh, pi times 5 squared. And the radius is 5. So notice 5 squared is 25. So we have 25 pi over 2. So we just found the definite integral of this function. The catch won't come today. Okay, all we're doing today is we're calculating areas. So negative areas. Well, notice both of our answers so far, we've only had positive answers. So anybody want to take a stab at what a negative answer might mean? We're doing an integral.
It's under the x.
It's under the x-axis. So that's what this says. When computing the value of definite integrals, areas that are below the x-axis are considered to be negative. So below the x-axis is negative. That's what we got to remember. Okay, it says consider the following function f of x. Write the integral that yields the area between x equals -6 and x equals 8, and compute the value of the integral by finding the appropriate areas. So first it says write the integral. That means write the correct notation. Okay, one note, as I'm grading your test, a lot of you guys are just leaving off notation altogether, and it's resulting in you making mistakes and making it almost impossible for me to understand what you're doing. Okay, so notation is especially important when we're doing integration. So we're going to integrate from x equals -6 to x equals 8. So the lower bound right here is -6, and the upper bound is 8.
So it says that a solid number always goes on the bottom?
No. But because it says find the area that, write the integral that yields the area between x equals -6 and x equals 8, this gives us the area between x equals -6 and x equals 8. Well, if the smallest number always on the bottom, the answer is no, it doesn't have to. But for what we're doing right now, the answer is yes, it should. That will yield this area. Yes, it matters. Okay. So let's break this shape up into some different shapes. In other words, we've got some different things going on here, right? But right here, what shape is this? Triangle. And then we've got a rectangle all the way over to here. And we've got another triangle. And then we've got what appears to be a semicircle. Okay. So let's find this first area. So that would be 1/2. Now the base of this triangle, -6 to -4, must be 2. And the height of this triangle is 2. Plus, so notice this, I'll put it in parentheses just to group it. This goes with the first shape. Then we've got another shape. I'll change colors here. All right. So that's a rectangle, which has the formula of length times width or base times height. So from -4 to 2, that's 6 units. And the height of this rectangle is still 2. Colors again. Plus. Now we've got another triangle. So we've got a base, we have 1/2 times the base from 2 to 4 is also 2. The height is 2. And then we have an area below the curve. Okay, so since it's below the curve, it's negative. We have minus. Now this is a semicircle. What is the radius of this semicircle? Well, since this is going from 4 to 8, this diameter is 4, which makes the radius 2. So from here to here, it's just 2. So we have 1/2 times pi times 2 squared. Okay, so our integral, we got 1/2 times 2 times 2, which would give us 2, plus 6 times 2 is 12, plus 1/2 times 2 times 2 is 2, minus 1/2 times pi times 2 squared. Well, half of 4 is 2 pi. Okay, half 4 pi is 2 pi. And so we get our final, the value of all this area here, or the integral, is 14 plus 2, which is 16 minus 2 pi. So the integral from -6 to 8 is 16 minus 2 pi. Now notice the total area here, the total area, if we were to add up all of the areas, well, if we're just adding area, area can't really be negative. Okay, so there is a difference between area and the integral. Okay, so when we're evaluating the integral, below the x-axis is negative. If you're just asked to find the areas, well, you just add them all up. Okay, so just a bit on the notation again. We call the a and the b, we call the a the lower limit, and we call the b the upper limit of integration. Okay, so if you're told the lower limit of integration is 2, the upper limit of integration is 7, that's telling you lower and upper. Okay?
Whichever one you see first is your A and the second one.
Yes. Okay. So that's pretty much it, believe it or not. There's really no catch just yet except for the negative. You gotta remember below the x-axis is negative. So yeah, we've got, I don't know, 10 problems or so, I think, 12 problems.